This is project 1.1, the Keypad voltmeter. Here's the finished PCB. Depending on the button pressed, it changes the voltage drop in the final 1K ohm resistor. It's complete with the digital voltmeter, which measures the voltage drop in the final 1K ohm resistor, and a 2-position terminal block, which allows you to insert your own DMM to verify the results. Here's the prototype for the Keypad voltmeter. Buttons 1 and 2 are connected directly to power, meanwhile buttons 3 and 4 share a 4.7K ohm resistor. Buttons 2 and 4 share a 1K ohm resistor, and all 4 buttons feed back into a 1K ohm resistor, which leads to ground. Depending on the button pressed, the current flows through a different set of resistors, which changes the voltage drop in the final 1K ohm resistor. This prototype consists of 4 momentary push buttons, 1 4.7K ohm fixed resistor, 2 1K ohm fixed resistors, and 6 hookup wires and a 9-volt power supply. The purpose of this project is to demonstrate Kirchhoff's voltage law, or KVL. KVL states that the sum of all voltage drops in a circuit is equal to 0. The voltage is divided across the loads, or in this case resistors, depending on their resistance. Here is a simple voltage division calculation. To find the voltage drop for any given resistor. In this case, we're using the 1K ohm resistor at the end. Here you can see that when key 1 is pressed, you have 9 volts for voltage drop, key 2, 4.5 volts, key 3, 1.579, and key 4, 1.343. We can confirm this using a DMM. So 4.5, and 9 volts from the power supply minus the 4.5 voltage drop in each of the resistors gives us 0, confirming KVL. Another way we can do this is by applying Ohm's law in KVL. Ohm's law is voltage equals current times resistance. As you can see here, we substituted voltage for the 2 resistors with current times resistance. We can then substitute these values in to confirm the DMM readings, as total voltage divided by total resistance gives us the current, 4.5 as the current, and we substitute that in and find that the DMM readings still hold true in theory. Returning to the PCB, a 3-position terminal block is used to provide a more accurate reading for the digital voltmeter. A 9-volt power supply feeds into the power jack, which provides power to the circuit via a 2-position terminal block. Finally, the resistor network is connected similarly to the prototype, but using traces on the PCB instead of the wiring in the prototype. Both the PCB and prototype confirm KVL through their DMM readings.